Hello everybody, Namaskar. This is Dr. Delnaz Jokhi from JG College of Commerce. Today we are going to start the chapter Integration with you. Well, if you are associated with Gujarat University, then this chapter Integration is unit number 1. It is useful in semester 5 of TY, and the subject, as you see, is Statistics 5. So let's start with this chapter, Integration. The points that I will be discussing with you today in this chapter would be, first I would be introducing into the entire concept of integration to you. Then we shall be looking at the definition of integration, that is simple integration, that is also known as indefinite integration at times by students like you. Then the concept of definite integration will be discussed, followed by the uses of integration. So my dear students, today we start the new chapter with an important theory often asked in the examination at Gujarat University in particular, and that is, if you have a pen and paper, write it down. The important theory is, write a short note on integration, or they might say, give the meaning of simple integration and definite integration, and what are the uses of integration in commerce in particular. So let's roll it. Let's start with this important question and a very important and a very interesting chapter, integration. Well, before I actually start with this, I always believe that curiosity and questions make great discussions between you and me. So, what do you see on your screens? All right, you see a kind of a graph. You see a kind of a line. Absolutely. What you see in green color is the x-axis, the blue color is the y-axis, and the red color is a kind of a curve. Now, just go back a little, rewind a little to your previous semesters. You had studied something, a particular chapter in which you had studied how to find out the change in the slope of that red color curve that you see. Do you remember? Oh, that smiley also is asking you. Do you remember? How would you study the change in something, in particular, the change in the slope of the curve of the line? Think. Remember, you've already studied this. All right. Mr. Smiley says he'll give you a hint. And the hint is, see what Smiley says. Do you remember dy upon dx? Now, my dear student, you feel, yeah, this feels familiar. I have done something like this. Absolutely. You have studied a chapter called Uses of Derivatives. You have studied a chapter called Differentiation. Do you remember now? Yes. You have studied differentiation. You have studied how to find out the derivatives of functions. Absolutely correct. They helped you to find out the slope. They helped you to find out and study the curve itself. That is why you study dy upon dx. I think thoda sa aapko bhi yaad aa gaya. But now, my dear friends, why this chapter, integration, is the curious question which should come to your mind. Well, how would you find the area below the curve? You see a small graph kind of a thing over there? Yes. Now, the curve over here is green in color, and the area below that curve, light green in color. Now I say I don't want to study the curve, but I want to study the area below the curve. Then how do I find out the area below the curve? And yes, you all are commerce students. So, being a commerce student, it's very important to find out total revenue function. How will you find out total revenue function? One more thing. Since you're a commerce student again, How do you find out total cost function when something is given to you? A few more curious questions. That is, imagine that we want to work backwards. What do I mean by backwards? Let's say, suppose, let's take the first one. Suppose you're talking about finding out, you're talking about some research on some kind of drug, for some patient. You already know the rate of absorption of the drug in the body. Rate, pata hai. Rate is related to that slope on the graph. But now you know the rate, but you want to find out the amount of that dawai or the drug which is absorbed in the body. Let me give you a more simple example. Let's take the population of some bacteria, or let's take some population of our country, India itself. Let's say, suppose you know the rate of growth of the population. Rate of growth आपके पास है, उसके ऊपर से with the help of the rate अब आपको उल्टा काम करना है. You want to find out the population of India. You are working backwards. So, my dear student, well, there are so many questions, and that method which helps you to find out the answers to all the questions that we just discussed, how to find. Those questions are answered by integration. So I think now you realize that if you're a commerce student, integration is definitely a very important chapter to understand. Right. Do you remember that smiley fellow? He had written dy upon dx. Absolutely. dy upon dx was how you denoted the derivative or differentiation chapter. You were using it, dy upon dx. So that was to denote differentiation, how you found out the derivative. Integration के लिए भी ऐसा ही कोई symbol तो होगा. All right. What is the symbol of integration? Do you see that little golden curve over there? Absolutely. That is the symbol of finding out integration. Okay, so now I have told you that integration, you have to remember that integration is the inverse of differentiation. Okay, and as you read on your screen, integration is also known many a times as antiderivative. Now, you must be wondering that why is integration the inverse of differentiation? Usko inverse क्यों बोलते हैं? Why is it known as antiderivative? Inverse माने उल्टा, remember? Alright, please make a note of this, that integration is the inverse process of differentiation. Write down the word inverse in your books if you have to make notes. Then, why is it so? All right, your question will be answered over here. What do you want and what do you see on your screen? Well, what happens is, over here, quickly, if you go to see, you see something like total revenue on your screen? Yes. You see something like marginal revenue on your screen? Absolutely correct. See, total revenue is here, derivative is here, marginal revenue is here, and your new concept of integration is there. Now, what is this? Why do we call integration a reverse process of differentiation or an inverse process? Let's see. If you, as I said, if you recall your previous semesters, total revenue was given to you. Total revenue आपको दे देते थे. और total revenue function, जब आप total revenue function का derivative ढूंढते थे, क्या मिलता था आपको? Oh, if some of you have got it correct, good. When a total revenue function is given to you, if you find out its derivative through differentiation, the answer which you will be getting is known as the marginal revenue. Alright, तो ये तो आप कर चुके हो कि total revenue आपको दिया गया है, derivative ढूंढो, marginal revenue आपको मिल जाएगा. But Why is integration known as the inverse? Now see, things have changed. Suppose now the marginal revenue is given to you. आपके पास total revenue नहीं है. आपको total revenue ढूंढना है. You have to work backwards. So, if marginal revenue is there with you, आपके पास क्या है? Marginal revenue का data का function आपके पास है. How will you find out total revenue then? Well, dear students, integration. Through the method of integration. If marginal revenue is given to you, by integrating it, you can find out total revenue. I think you have understood now that first process is total revenue से आप नीचे आए, आपको marginal revenue मिला, derivative, and the other scenario is the inverse of it. उसका उल्टा है क्या? एक अगर marginal revenue आपके पास है, उसको आप integrate करोगे. See, this arrow is going down and this arrow is going upwards. So there are two inverse ways of solution. So when marginal revenue given, integrate, what do you get? You will get your total revenue. That is why I think I justify, and आपको थोड़ा सा समझ में तो आ गया होगा कि that is why it is the inverse process, and integration may also be known as antiderivative. Great. All right. Always remember, in all my lectures, 99.9% of the times you will have a quiz, so that I know how attentive you were. Take a paper and pen. We start with the quiz and your first question. Listen and read. Is integration the inverse of differentiation? Yes or no? You have a paper and pen with you, I'm sure for that. Just write down your answer. Is integration the inverse of differentiation? Only one answer, yes or no. All right, time up. Coming on to the second quiz question. Listen and read carefully. Is the technique of integration used to find out total cost when marginal cost is known to you? Marginal cost अगर आपको दिया हुआ है, तो क्या marginal cost को integrate करके क्या आपको total cost मिलेगा? Yes or no? Please write down your answer. You have around 10 seconds to answer both. All right, time's up. Well, is integration the inverse of differentiation? Yes, we just saw it in the previous slide, so I'm sure your answer is correct. The first answer is a yes. And my dear students, the second answer is also a yes. I just gave you an example of not marginal cost. I gave you an example of marginal revenue, and from the marginal revenue, you found out the total revenue. Same way, if you have been given the marginal revenue, then with the help of integration, yes is the answer. Yes, you can definitely find out the total cost when the marginal cost is given to you. So check your answers. If you have both the answers as yes, wow, great. You have paid good amount of attention to what I just taught you. Great, congratulations. So your base for this chapter is quite good now. So let's go ahead. Now, let's look at the symbol of integration. If you remember, I had discussed this in a short bit with you, but now let's talk about it in detail. What do you see on your screen? It says summation of all small areas below the curve will give the total area you require to find. That is integration. Let's make it a little bit more easy for you for the help of this little graph for you. Do you remember I told you that whenever you have a curve and if you want to find out the area below the curve, what is the method that you'll be using? Yes, correct. You'll be using integration. Now I'm discussing that how did integration get this particular symbol that you see. Yes, this is a symbol of integration, but how do you get this symbol? Why the symbol? Well, do you see this graph? Yes. if you want to find out the area below the curve, what do is, you suppose that you divide the entire area into small areas, and you find out those small areas. Now, but naturally, when you have the small areas with you, and when you add up, adding in statistics and maths is summation plus. Do you remember? All right. Integration means summation. आपको कुछ plus करना है. क्या plus करना है? वो कर्व के नीचे जो छोटे एरियाज है, अगर सारे एरियाज को आप ऐड करते जाओगे तो you will get the entire area below the curve. So what are you doing? You are doing summation. Summation of what? Summation of all the small areas below the curve. उन सबको आप summation करते हो. And now you must be saying, I have made this S as red and the symbol also as red. Well, वो S को थोड़ा सा खींच लो. In English, as you say, if you elongate that S, it will look like this symbol of integration. See, what a lovely story to know how the symbol of integration comes. Integration means summation of all the areas. Pull that S a little, elongate that S a little, and that elongated S looks like the sign of your integration. I think you understood why and how the symbol came. All right, so now let's get a little technical. Definition of integration. Well, let's just see it again. If gx is any differentiable function of x, and if gx upon dx is equal to fx is your function, right? Then gx is called the integral of fx. I think you all know what fx is. Fx is a function, right? Okay, so over here you get gx, which is called the integral of fx with respect to x. And how do you write this symbolically? Well, it is written something like this. Don't worry. You are doing this chapter for the first time. You are looking at this for the first time. As the lecture goes ahead, things will become easy for you and you'll become familiar with it. Just understand one simple thing. What is this? The sign of integration. What is this? fx dx is equal to gx. Currently, you understand that when you integrate a function with respect to x, the answer which you get is the integral. Okay, now let me make the meaning of integration a little easy for you. All right, the easier one. The process of finding integral of a function is known as integration. And what is integral? That little gx which you see over here is the integral. So what is the meaning or definition of integration in simple? Integration is a process of finding out what? Of finding out the integral. Integral of what? Integral of a function. Function is fx. So that is called integration. It's simple language for you to learn in this first lecture. Now, the notations which you saw over there were looking little naya to you. So let us understand the notations used in the definition which I just discussed with you. Now I think you all know what this elongated S is. It is a sign of integration. Am I right? I think this is clear to you. What is this fx? Yes, fx is a function, but it has a technical name. Please note down these small things. I'm going to ask you a quiz in some time. Remember? Right. So fx is known as integrand. Integrand. That's the function. What is this gx? I just told you what gx is. Gx is the answer which you get after you integrate it through some formula. So gx is known as the integral. Please make a note. fx is known as integrand, and gx is the answer which you get is known as integral. Okay? Check the spellings and write them properly. Moving ahead. Yes, we didn't talk about this little dx over here. Well, dx is known as the differential. Differential, that is, dx represents the integration with respect to x. Now, why is this dx called differential? I'll just make it very easy for you. See, I told you that integration is the reverse of finding out your derivative. If you remember a little, आप कभी-कभी dy upon dx ढूंढते थे और कभी-कभी dx upon dy ढूंढते थे. That means when you had studied that chapter, you were sometimes doing the sum with respect to x and sometimes doing the respective sum with respect to y, depending upon the situation, what is needed. So over here, this dx is very important. It is a differential. Please make a note of it. Dx is known as the differential. You know what fx is and now you know what gx is. So this differential tells you that yes, you have to integrate this function. But the sum was previously done with respect to x. So that is why I hope you have noted dx is known as the differential. All right, the quiz in front of you. You see three things on screen, right? It's a quiz based on the notation which I just discussed. Integrand, tell me what it is. Write down as a quiz answer. Differential, abhi kiya, it's very fresh in your mind. Write down what is the differential. And integral. I give you 5 seconds. Quickly write down in your notebooks the notations of these three. The time starts now. All right, very good. If you have really done what I have said, and I'm sure you're a good student, you must have done it. I'm very positive about it. Integrand is your fx, right? Differential is your dx. I'm sure sabko ye sahi aaya hoga. And integral is your gx. Right? And my dear students, you must have written fx, dx and gx. In तीनों के बीच में, if at the starting you put the sign of integration and between dx and gx, if you have this equal to sign, do you remember? This was the definition, the mathematical way of defining integration. So see, what you found a little bit confusing and a little bit difficult in the starting, just few minutes before, I think now it is getting easier for you. Well, the same way, we shall learn this chapter with lots of fun, understanding and illustrations. Coming on to another important concept, and that is definite integration. Now you must be wondering that, man, we just did integration. What is this definite integration? Well, very good question. If it is there in your mind, well, if you remember, I told you that the integration which we did was simple integration. It was indefinite integration. I'm again using the words. अभी जो हमने definition किया was of simple integration. दूसरा नाम क्या है simple integration का? Just integration or indefinite integration. ऐसा क्यों हम बोलते थे? Because if you remember, we were studying the entire area below the curve. Right. But the name over here is definite integration. Let's make it a little clear for you. Do you see that curve over there now? Yes. Now see, this on the y-axis, as you now know, on the y-axis, we always take your function fx, right? And on the x-axis, we take the values of x. And for different values of x, when you substitute the different values of x into your functions is equal to y, you will get several points. When you join all those points, you get your curve. And when you want to find out the area below the curve, you use integration. Super. Now, over here, below this particular curve, I don't want to find out the entire area. I just want to find out the small part from A to B. I want to find out a definite part, a definite fixed area below the curve. So if you see very carefully, यहाँ पे 0 होता है हमेशा, origin, right? Origin से इतनी जगह छोड़ दी, and you have A. Let's say, suppose this A is equal to, let's say, number 2 on your axis, and this B is, let's say, number 8 on your axis. So which is a bigger number? 2 is bigger or 8 is bigger? Yes, absolutely correct. 8 is bigger, 2 is smaller. So you want to find out the area below this particular curve only from x is equal to 2 to x is equal to 8. So you want to find out a definite part of the area. So that is why, my dear students, when you want to find out a fixed part, a definite area below the curve, you use not the concept of simple integration, but you use a more specific concept of integration, and that is known as definite integration. I'm sure you understood a little. All right, now let me look at the definition of it over here. What is the definition of definite integration? If fx is a continuous function, okay? fx is a continuous function. Please remember the word, quizzes are coming up. If fx is a continuous function in the closed interval a comma b, I think when you look at the graph, you have understood what is a. Remember I told you let it be number 2, and what is b? What did I suppose for b? Do you remember? Correct. B we had supposed as 8 is a number on the x-axis. Superb. The integration of fx between the limits, see, a fixed limit is given to you. Limits a and b is now known as definite integral. Okay, so if this is understood a little, let us see how it is mathematically noted. Look over there. It is, this sign is of integration. You remember fx, you remember the function. Dx, yes, you remember. You have to do the sum with respect to x. This gx also you know very well. Now gx is known as the integral. Perfect. What is different between the previous one and this one is, now you have a definite range to find out. So whenever you talk about integration, you have to write down the interval. A, the smaller number is down. B, the bigger number is up. And same way, when you get the integral, you just put a bracket and write down your range. What was your range? A to B is equal to GB minus GA. Now let me make it easy for you. Why GB minus GA? Well, it is common sense that if you take from this y-axis over here, this is your big area, you know, 0 to B is your big area, and this point of origin 0 to A is your small area. Common sense. How will you find out the remaining area? Simple. Big area, that is up to B, minus the small area, that is up to A, will give you the remaining area. Simple. 6th standard mathematics, big number minus small number. Correct? That is why big number B is substituted in the place of X. So you get GB minus, then the small number A is substituted in place of this X. So you get GA. I'm sure you have understood what is definite integration, fixed, and what is simple integration. जिसका दूसरा नाम क्या है? Indefinite integration. All right. Now, I told you that if you are a student of Gujarat University and if you are going to study this chapter, then from the examination point of view, this theory. What is theory? Simple uses of integration. Very important question. Many a times asked in the university exams, either in the form of a long note or in the form of 2-3 marks or in the form of 7 marks. So let's see. What are the simple uses of integration? The first one, what does it help you to do? It helps you to find out the area below the curve. I think you know that very well. Then I told you, and we also saw, that integration helps you to find out total revenue and total cost. How? Provided the MR is nothing else but the marginal revenue is given to you, and MC, that is the marginal cost function, is given to you. So my dear students, if marginal revenue or marginal cost function is already given to you, then if you integrate that function, with respect to x, then the answer that you get, the integral, is nothing else but the total revenue and the total cost respectively. So first use area below the curve, we all know that. Second use total revenue, third use total cost. Now, if you are a student of commerce, or maybe you're working in a company as a manager, many times it becomes very vital to find out the total inventory carrying cost. Integration helps you find out the total inventory carrying cost also. How it helps you, we'll be checking out in the coming lectures when we do our various types of sums for integration. And the last use, important one. See, there are many uses of integration, but keeping in mind your syllabus, these are some important ones which I have listed for you. All right? How do you find out profit and loss? How is integration useful to find out profit and loss? Well, that naturally, if you have total revenue and if you have total cost with you. TR minus TC, total revenue minus total cost function, which you will find out, will help you to find out profit. Same way, when all TR, TC and other details are given to you, you can also find out break-even point. Yes, you can also find out loss and you can also find out profit. So I'm sure that area below the curve, total revenue, total cost, total inventory carrying cost, and the total profits and losses. If you are a manager of a company, how will you find out? Integration will help you. All right, so I think the uses are clear to you. Quiz again, right? Pay attention, get your paper and pen with you quickly. When you want to find a fixed area below the curve, let's say between A and B, then what would you do? Quickly take your paper and pen and tell me. Okay. Okay. And would you use the method of definite integration in that? Yes or no is the question. All right. Is the technique of integration used to find marginal revenue when total revenue given to you? That is your second question. So quickly find out. Come on, what's your answer? Great. When you want to find out a fixed area below the curve, you do not use indefinite integration. You use something called what? You use something called definite integration. All right. Now, what about your second answer? Think, take a break of 2 minutes, write down your answer, we'll come back. Oh, I'm here again. So the answers are no for the first question and what? No for the second question also. How many of you get it correct? I don't know, I can't see you, but then I'm sure the first one must be correct, that indefinite integration is not used to find out a fixed area. It is definite integration which is used, correct? And when you want to find out marginal revenue, आपको marginal revenue ढूंढनी थी. When total revenue was given to you, integration is useful for that? No. You were using the concept of derivatives. So the answers to both the questions are no. Okay? If marginal revenue is given to you, then through integration you can find out total revenue. But यहाँ पर तो उल्टा है. So that is why the answer to both the quiz rounds is no. Now, over here, if things are clear to you, oh, that bird flies away. Let's see the points that we have covered in today's lecture. Just before I fly away, like that little bird did. All right, now, we did the introduction to integration. after the introduction, and where all it is very useful to you for doing the backward working, if you remember all those examples, right? We discussed the definition of integration with you. Remember that? Yes. Then we did the essential notations. Remember? fx, dx, gx, all those. Then a very important concept of definite integration was discussed with you. Yaad aaya na? When you want to find out a definite area below the curve from A to B, you use the concept of definite integration. But if you need to find out the entire area below the curve, you use the concept of indefinite integration or just simple integration. Finally, you saw the various uses of integration. Remember, area below the curve, total revenue, total cost. What else? Inventory concept was also covered, and profit and losses. So my dear commerce students, integration is a very important chapter. The sums are very interesting. Those I will be covering in the future lectures. As of now, Dr. Delnaz Jokhi says a big thank you to you for listening to my lecture. Thank you. God bless you. Namaskar. And lots of good and happy learning to all of you. Thank you. Bye-bye. God bless you.